Next we will look at some practical kind of black body, that is cavity radiation we call it. As I have told you earlier that like any theoretical black body, we can imagine any black body like all kind of radiation is incident on a body and it absorbs everything, but it is not useful to construct some mathematical model regarding some abstract kind of black body that we have already imagined. So we consider a cavity radiation. So it is the means use of imagining a cavity is nothing that we can construct a mathematical model of a black body, and we can calculate everything like spectral radiancy, energy density. What is it we will see soon. So like what is cavity radiation is that we just imagine a cavity of a arbitrary shape with a hole in it. The inner surface area of this cavity is so much larger than the small hole in it. So any kind of radiation that incident on the hole is like reflected to and fro inside the wall. So there is a very less probability that it will go out in through this small hole, because the area of this cavity is so much higher than this hole. So what is it that any kind of radiation that is incident in this cavity through this small hole is trapped inside this cavity. So it has the similarity with the black bodies. As black body absorbs everything inside around it, this small hole and this cavity also absorbs everything. So we can call it a black body now. So like as it has the absorption characteristics similar to the black body. So if we heat it up to a particular absolute temperature T, it will also emit some radiation through this hole. So as it absorbs everything, it should also emit everything. So it has the characteristics similar to a black body. So it will emit every radiation that is of universal character as it is in a black body, and it will have a continuous spectrum, and we will see the same kind of graph as we had already discussed. So energy under this is spectral radiancy, that is total energy, and in this we have this is radiancy, this is spectral radiancy at a particular temperature T. So what is radiancy? As we have told that this is the energy radiated per unit time per unit area. So like this is a case of two-dimensional. So the cavity is a three-dimensional thing. So we consider another parameter, that is energy density. That is energy emitted per unit volume per unit time. It was per unit area, so it is we can call it the energy flux. So if it is energy flux, it is energy density. Now we will see that we can, like this cavity was of arbitrary shape, so we can imagine of any kind of cavity. So we will see in a little while how can we construct mathematical model regarding this cavity radiation. Before that, we will see a simple law of radiation, that is Kirchhoff's law for radiation. E1 is the emission coefficient, A1 is the absorption coefficient. So what we have done here is that we have imagined two objects. There is no medium between them, so whatever the body A emits absorbs the second body, and whatever second body emits absorbs the second body. So relation between the emission coefficient and absorption coefficient between two bodies is equal to 1. So whatever it emits is absorbed by the body, and whatever the second body emits is also absorbed by the second. Sorry. It is a very basic thing, cause in a enclosed system, according to conservation law, whatever is body emits should be equals to the whatever it absorbs.